In the remote wilderness of Siberia, near the Podkamenia Tunguska River, an event of colossal magnitude occurred on the morning of June 30, 1908. At around 7:17 a.m. local time, witnesses reported a blinding flash, a thunderous sound, and a shockwave that flattened an estimated 80 million trees over an area of 2,150 square kilometers. This was the Tunguska event, a mysterious explosion that has puzzled scientists and sparked countless theories for over a century. The explosion was so powerful that it registered on seismic stations across Eurasia, and the atmospheric pressure wave was detected as far away as England. Yet, remarkably, no impact crater was found. What could cause such devastation without leaving a scar? This video delves into the details, the evidence, and the leading scientific explanations for one of the most intriguing natural disasters in recorded history. The first-hand accounts from the Evenki people and local settlers describe a sky split by a fiery object moving north to south. One witness, Sab Semenov, who was about 65 kilometers away, recalled a bright light that grew so intense it seemed to set his shirt on fire. Then came a deafening blast that knocked him off his feet. The shockwave shattered windows and felled people hundreds of kilometers away. In the town of Kirensk, 450 kilometers from the epicenter, the ground shook violently. The air temperature fluctuated wildly, and for several nights afterward, the sky glowed with an eerie luminescence, allowing people to read newspapers at midnight. This bright nights phenomenon was observed across Europe and Asia, attributed to high-altitude dust from the explosion reflecting sunlight. Yet, due to the remote location and the political unrest in Russia, a scientific expedition to the site would not be mounted for nearly 2 decades. It was not until 1927 that the first serious scientific expedition, led by Russian mineralogist Leonid Kulik, reached the Tunguska blast zone. What he found was astonishing: a vast expanse of charred, flattened trees radiating outward from a central point. But where an impact crater should have been, there was only a shallow swampy area. Kulik initially believed a meteorite had impacted, but the lack of a crater and any sizable fragments puzzled him. He conducted several expeditions, drilling into the permafrost and digging trenches, but found no meteorite debris. Subsequent Soviet expeditions in the 1960s found microscopic spheres of silicate and magnetite in the soil, possibly extraterrestrial in origin, but not enough to account for such a massive explosion. The absence of a crater and the pattern of treefall radial with a central stand of upright but scorched trees pointed to an airburst rather than a ground impact. The most widely accepted explanation for the Tunguska event is that it was caused by an airburst of a small asteroid or comet. Calculations suggest that a stony asteroid about 50 to 100 meters in diameter entered the Earth's atmosphere at a speed of roughly 15 to 30 kilometers per second. The immense friction and pressure caused it to explode at an altitude of 5 to 10 kilometers, releasing energy equivalent to 10 to 15 megatons of TNT, about 1,000 times the power of the Hiroshima atomic bomb. This airburst would generate a shockwave that flattened trees for kilometers, but because it occurred in the atmosphere, no impact crater was formed. The heat would have vaporized most of the object, leaving only microscopic dust. The radial pattern of tree fall, with trees pointing away from the epicenter, and the central standing trees, which were shielded by the blast's vertical component, matched this model perfectly. While the asteroid airburst theory is favored, some scientists argue that a comet could have been responsible. Comets are composed largely of ice and dust, making them even more likely to disintegrate completely in the atmosphere. The high-speed entry of a comet could also explain the bright nights and the lack of rocky debris. However, comets are typically less dense than asteroids, so a larger object might be needed to produce the same energy. Another theory suggests a natural gas explosion from a methane pocket, but the seismic and atmospheric data don't support it. A small black hole, antimatter, or alien spacecraft theories have been proposed but lack scientific evidence. One intriguing hypothesis is that the object was a near-Earth asteroid that fragmented in a way that produced an airburst with no crater. Ongoing studies of similar events, like the 2013 Chelyabinsk meteor, support the airburst model and help refine our understanding of Tunguska. Today, the Tunguska event serves as a crucial case study for assessing the threat of asteroid impacts. It is a stark reminder that devastating explosions can occur without warning. In 2013, the Chelyabinsk event, while much smaller, demonstrated that even a 20-meter object can cause injuries and property damage. Scientists now estimate that Tunguska-class events occur once every few thousand years, but the risk is real. Advanced space observatories like NASA's Near-Earth Object Observations Program track potentially hazardous asteroids, and planetary defense strategies are being developed. The Tunguska event also influenced popular culture, appearing in films, books, and video games. While the exact cause may never be definitively proven, the consensus points to an asteroid airburst. As we continue to monitor the skies, Tunguska remains a powerful symbol of the awesome power of the cosmos and the fragility of our planet.